Good morning, friends. Here we are presenting the lecture series about vibration analysis of mechanical system. In this lecture series, we are basically going to discuss how we can practically use the vibration analysis for the design and maintenance of various machineries, various components, and this lecture series particularly infuse the theoretical as well as practical aspects of analysis of various mechanical systems, right? It could be a beam, it could be a engine, it could be other sort of systems which generally having disadvantage of vibrational failure. And so in this lecture series, as we are going ahead, we will discuss all the subject. Let's come to about the objective of this lecture. In this lecture we will discuss few basic terms, the terms which we will use in lectures coming ahead, and also about the aspects of different vibrational condition, right? Okay, so let's begin with the basic concept, right? So vibration generally occurs in those component which has rotatory or translating motion, right? So in general terms, if we talk about vibration, if something is moving back and having back and forth motion, it is said to be in the state of vibration, right? So it the literal idea what we can get from the term vibration: if a particular component or machinery is subjected to vibration, it internally has excessive stresses, right? Noise is one of the problem, and parts which are in assembly get loosened up, and this ultimately results to partial or complete failure of a system. In For example, if we go that locomotives, diesel engines, unsound foundations, and the whirling shaft, right? Whirling shaft is generally used for the turbine, and where we have connectivity between a power producer and a receiver part where we attach a shaft. So all these things subjected to vibration when they are in the condition of operation. One point I would like to explain here is the unsound foundation. As far as we talk unsound foundation, it generally relates with the term how much vibration that this foundation in which a system placed upon can observe, right? On that basis this unsound foundation is classified, right? So the vibration occur in the system should be transmitted to its base. Okay, now vibration analysis, as I said in the beginning, is all about the designing as well as the maintenance part, right? So bearing, couplings, and other things whichever is having a rotating or translatory motion is generally subjected to vibration. Okay, now these are the few basic terms which we will use frequently in the lectures coming ahead, and in this particular lecture also. First one is frequency, right? So frequency in general meaning we can say about it that uh, number of cycle, that how many cycles a particular system is going to complete within unit time. It could be per unit second, it could be per unit minute, per unit hour, depending upon the units in which we are defining, but in unit time how many cycles a particular system is completing, right? Similarly, angular frequency denotes that how much fast an object is rotating, right? So it is just an advanced version of frequency, right? So how many rotations a particular system is going to complete within unit time, so it will show us the angular frequency. Its unit certainly in radian per second, as we are talking about rotation, right? Third one is amplitude, right? So the maximum displacement of vibrating body from the mean position, right? This we will discuss more later. Third term is resonance, right? This is going to be very important term. right? Before that, I would like to introduce one more term which is called natural frequency, right? Natural frequency is something by which system oscillates from its mean position. This is called natural frequency. This is the maximum amount or maximum amplitude a system could get. So this is called natural frequency. When a system placed in operation and start having a motion with the pace of natural frequency, this particular situation is called resonance, right? So what we can draw out from its meaning, when a system is subjected to resonance, its amplitude is very high, it is in the peak. So it is a very dangerous situation. We do not want to get up to resonance, because beyond that there is nothing and system is ultimately going to get failure, right? Now the next term is degree of freedom. Degree of freedom is something that how many variables are required to completely define the motion of a system. This is called degree of freedom, right? How many independent variable, to be precise in that sense. The next term is simple harmonic motion. The most of the vibrational condition, just for to simplify the analysis, we use simple harmonic motion to derive the equation and etc etc task. It shows some easiness to analysis of the system. So when a periodic motion of a particle whose acceleration is always directed towards the mean position and also proportional to its distance from the mean position, right? This is what called the simple harmonic motion. And the another definition we can have for it, the projection of particle moving around a circle with uniform angular velocity, right? Suppose we tied up a ball with a thread from a fixed position and started rotating this particular ball in a circle. So if it move around the circle with a constant angular velocity, this motion could also be quantified as a simple harmonic motion. Now the next term is damping. Damping in literal meaning we will discuss in later lectures in more detail. Damping is resistance to the motion of a vibrating body. That means we are trying, with the help of damping, we can damp out those vibrations which occurs in the system which are undesirable, right? Equilibrium, as name suggests, that when we are talking about balance, right? Balance of horizontal forces, vertical forces, as well as movements developed within the system. If all these things are balanced, the system is called an equilibrium. Although it is very hard to achieve that equilibrium, but we are trying to get it to that position, right? These are few basic terms. There are many, but these are the important terms enlisted in this slide. We can have more of it, but these 7-8 terms we need to remember throughout when we are talking about vibration analysis of any system, right? Now let's get to the another thing, that how vibration occurs in the system, right? As I was defining the equilibrium part, I said that it is difficult to get the equilibrium, right? If it is difficult to get the equilibrium, it means some unbalanced forces will retain within the system and will cause system to move or operate beyond its limiting lines, right? So these are the unbalanced forces or movement which cause vibration within the system. Second point is dry friction between two mating parts. This also causes friction because you are retarding the motion basically with the help of friction. External excitation, right? If system is influenced by some external forces, so this also causes vibration. Earthquake is a very common example that we have heard a lot. Now types of vibration, right? We will deal and restrict our discussion in the whole lecture series between these two terms, free vibration and forced vibration, right? Because this will narrow down our path of vibration analysis to objectify the designing and maintenance process, right? First one is free vibration, right? When the vibration caused because of a component's own elastic properties, no external factor is involved in this sort of vibration is called free vibration, right? So natural frequency does have very much influence in this sort of vibration. And as we are saying it, that means to analyze the free vibration condition, we need to determine the natural frequency of the system, right? It could be of any case using differential equation, generating lot of data. It could be anything, but we need to determine the natural frequency here, right? And essentially it is the critical factor in terms of uh, defining the effect of free vibration. Second term is forced vibration. As its name suggests, it has influence of external periodic forces, right? So the frequency of vibration in this case is same as that of excitation. That means that whatever be the frequency that external force is carrying, it also replicate the same uh, part of frequency which will appear to be acted upon the system or that particular component.